Imagine it's Black Friday. Your e-commerce platform is live and millions of customers are hammering the place order button all at once. Traffic is at an all-time high. Dashboards are green. Everything looks perfect. And then an alert fires. Inventory is dropping fast. Product after product just vanishing off the shelf. But here's the part that makes absolutely no sense. Revenue isn't moving. Hours of digging through logs and traces, and then finally they find the pattern. The order exists in the order database. The inventory is locked in the inventory database. But the payment, it failed. And now thousands of products are locked up by orders that were never actually paid for. On the biggest sales day of the year. Now, how do you even fix something like this in a distributed system? That is exactly what the Saga pattern was designed to solve. And by the end of this video, you will understand it so completely, you'll be the one explaining it to your team. But before we fix it, let me take you back. Back to a world where this problem couldn't even exist. The monolith. In a monolith, a customer places an order, and the app needs to do three things: create the order, reserve the inventory, and process the payment. And here's the beautiful part. All of that data lives in one single database. So what do? We wrap all three steps in one transaction. Create the order, reserve the inventory, charge the payment, and commit. Everything succeeds. We commit and the whole thing is saved together, atomically. But if anything fails, we roll back the entire transaction. Every change already made by order and inventory gets revoked, like the whole thing never happened. That is the gift of ACID transactions. All or nothing, handled for you, automatically. Remember this feeling, because we are about to throw it away on purpose. So we move to microservices and we adopt what's called the database per service pattern. Every service gets its own private database. Order service has its own order DB, inventory service has its own inventory DB, payment service has its own payment DB. Nobody reaches into anybody else's data. And this is actually a really good design. Each service is fully autonomous, teams can deploy independently, and you can scale just the payment service during a sale without touching anything else. But we paid a price. A single transaction can no longer span multiple databases. That safety net we loved in the monolith? It's gone. And that missing net is exactly why those products got stuck on Black Friday. Let me show you exactly what went wrong. Step 1. Order service creates the order. Order created. Step 2. Inventory service reserves the stock. Inventory reserved. Step 3. Payment service tries to charge the customer. And payment failed. Now stop. The order exists, the inventory is locked, the payment failed. But two of those three steps already committed to their own databases. They are done. They are real. And here's the part that really hurts. You cannot just type rollback. There is nothing to roll back to. The transaction crossed service boundaries, and the moment it did, your rollback button stopped existing. This is called the distributed transaction problem. And this exact mess is the entire reason Saga was invented. So here's the core idea, and it's actually quite elegant once you see it. A Saga is a sequence of local transactions. Each service does its own small transaction, independently, in its own database, one after another, like links in a chain. If every step succeeds, the Saga completes. Beautiful, done. But if a step fails halfway through, we don't panic. We walk backward and undo each completed step using what we call a compensating transaction. And I want you to catch this one word because everything in this pattern depends on it. Not rollback, compensation. That one small distinction, that's the whole pattern. Let's go back to our order flow. Create order succeeds. Reserve inventory succeeds. process payment fails. In the monolith, we'd roll back, but we can't. Those first two transactions are already committed, and the database is not going to uncommit them for us. So what do we do instead? We run brand new actions that undo what already happened. The payment service sends a compensation event, release inventory, to the inventory service. Then the inventory service sends its own compensation event, cancel order, to the order service. The system is consistent again. The stock is back on the shelf and nobody got charged. That is a compensating transaction, a cancel that balances a create, a release that balances a reserve. This is the core of the Saga pattern. Now, the real question: who is actually running all of this? Who's keeping track, and who fires the compensation when things go wrong? There are two very different answers to that question, and they lead to completely different architectures. The first approach is called choreography. Think of it like a really well-rehearsed wedding dance. Nobody is standing in the middle directing everyone. Each person just knows their cue and reacts to what the person before them did. That's choreography. No central director, no boss. The services coordinate themselves by reacting to events. Order service creates the order, then publishes an event. Order created. Inventory service is listening for exactly that event. It reserves the stock, then publishes inventory reserved. Payment service is listening for that. It charges the customer, succeeds, and publishes payment processed. Order gets confirmed. Nobody was in charge. They just handed off control one to the next through events. But what if payment fails? Payment service publishes payment failed to the payment topic. Inventory service consumes this event. It releases the stock and publishes stock released to the inventory topic. Order service consumes stock released, cancels the order, and publishes cancel order to the order topic. The saga unwinds itself step by step in reverse. So why love this? No central component to maintain. Services are loosely coupled. They don't even know about each other, only about events. And it's very simple to start with. But here is where the problem begins. As your system grows, order, inventory, payment, shipping, notification, loyalty, invoice, the events start flying everywhere in one giant invisible web. If something goes wrong, where do you even start debugging? There's no single place where you can see the full picture, and cyclic dependencies can sneak in. Service A waits for B waits for C waits for A. Suddenly, nobody knows who should go first. The second approach flips the entire philosophy. Instead of letting services coordinate themselves, we hire a conductor. We call it the Saga Orchestrator. Think of it like a music conductor in an orchestra. Every musician is talented, but they all look at one person who tells them when to play, what to play, and when to stop. That conductor in our system is the orchestrator. One brain in the middle, controlling the entire flow. Let's walk the whole thing step by step. A user places an order. The order service saves it with the status pending, then triggers the saga. Now the orchestrator is in control. Step 3. The orchestrator sends a command, process payment, to the payment service. Payment succeeds and sends back a payment completed event. Step 5. The orchestrator commands the shipping service to initiate shipping. Shipping is done and sends back an order shipped event. Step 7. The orchestrator simply flips the order status from pending to confirmed, and the saga is complete. One brain, one place, complete control. And here's the elegant part. The orchestrator knows exactly where it is in the flow at every moment. So the instant payment fails, it immediately fires the compensations in order from one place. Release inventory, cancel order. The entire business flow lives in one place. Easy to read, easy to monitor, easy to debug. If something breaks, you know exactly where to look. So which one should you use? Choreography or orchestration? Honestly, there's no universally correct answer. Only the right answer for your system. Use choreography when your flow is simple, your team is small, and the number of services is low. Use orchestration when your flow is complex, when you need clear visibility, when debugging and monitoring matter. Most large organizations eventually reach for orchestration, and now you understand why. So let us quickly recap everything. The Saga pattern lets many different services complete one single business transaction, without needing one big database transaction across all of them. Each service does its own small local transaction going forward, and if any step fails, we go backward and undo each completed step using a compensating transaction. Use choreography when you want no central boss. Use orchestration when you want one brain in the middle controlling the whole flow. But there is a catch. Saga quietly creates a brand new problem. Your order data, your customer data, your payment data all live in different services now. So when your UI needs all of it in one single response, you can't just write an SQL join anymore. So how do you answer a complex query when the data is scattered across your whole system? That is exactly what we're solving next. The API composition pattern. If Saga finally made sense to you today, hit the subscribe button and click the bell icon so you don't miss any video from us. I'll see you in the next one.